So let's go over an overview here of what we're going to discuss this evening. First of all, we're going to talk about a quick review of Section 609 regulations. And then we'll hit the high points of the main refrigerant transitions. We won't discuss every possibility, but just those that right now show promise are kind of in the limelight. There are some refrigerant blends that are undergoing some review and testing right now that show some promise, but I'm not going to get into some of those extreme ones. And then I also want to talk a little bit about the mobile air conditioning directive in Europe and its ripple effects on the rest of the world. And the reason that I want to talk about that a little bit is that what's happened in Europe is going to likely have an impact on what's happening in the U.S. We are an international community right now, and everything we do is interrelated. And I also want to talk a little bit about the R134A counterfeiting issue. And then where we're likely headed. Take your questions, and we'll also talk about some helpful resources. Okay, just to recap some of the things on Section 609 is that the refrigerant recovery and recycling regulations were first released in all the way back 1992. It seems hard to believe, but that's when it first again was released with respect to controlling R12 release and basically responsible refrigerant handling practices. And at that time, the regulations were released with a term that is in federal law called for consideration, which means for hire. In other words, if you are doing air conditioning service work for hire, you do need to be, in federal terms at least, certified under a Section 609 program such as ASEs. And such programs include a combination of approved equipment and technician training/certification. Back at that time, there was also a sales restriction imposed on R12 because of its ozone depleting nature. Since then, there have not been any additional sales restriction issued as far as like on 134. And it's unclear at this point whether there will be one on the rumored new refrigerant of R1234YF. But in July of this year, the EPA issued some new guidance on refrigerant recovery and recycling programs, and we'll get into some of that as we get further on into tonight's webinar, and also we hope to address your concerns and the questions that you have. Okay, one of the common questions that we get often is the vehicle I'm working on covered by a Section 609 application, which is really MVAC, Motor Vehicle Air Conditioning, as defined under federal law, and I guess commonly known that as well, or is it covered under what's known as a Section 608 program, which is really more for stationary type of air conditioning systems, which there are 4 different varieties. And graphically, these pictures you see on the screen here are really provided right from EPA in a fact sheet that they have, which goes to show you the application. So as you can see, passenger cars, buses not using R22, which would mean they'd be substantially identical to a motor vehicle air conditioning system in a passenger car, and trucks would be 609 applications. And then in another term that they have called MVAC-like appliances, which are things such as farm tractors, construction equipment, those would also be covered, or could be covered under Section 609 or 608, 609 being the easier one to obtain. That would cover those applications. But then when we get over to other types of vehicles such as trains, aircraft, trailers, boats, and things of that nature, those are all 608 applications, and ASE's program would not cover those in terms of what's needed to work on. So I want to make that distinction clear. There is a little bit of overlap in the law, like for example, venting, or the prohibition of venting for that matter, is really covered under the spirit of a 608 law, but it spills over. But nonetheless, this is a quick graphical way to look at the type of vehicle you might be working on, and then knowing what certification program along with training would apply. I'm going to talk here just briefly about a warning on hydrocarbon refrigerants. This is something that the EPA wants to also focus on. Is to the best of my knowledge, these are the current states that prohibit the sale or use of hydrocarbon-based refrigerants in motor vehicle air conditioning systems. And these are refrigerants such as ASE 12, HC12A. There's a listing on the EPA website, and I'll be giving the URL out later for that, of refrigerants that are not accepted according to the EPA Significant New Alternatives Policy. And they have a chart of that that's updated all the time. Now I just want to quickly discuss a note here about our ASE A7 Heating and Air Conditioning Certification Test. The ASE Heating and Air Conditioning Certification, A7, was developed before the ASE Refrigerant Recovery and Recycling program ever came along. And it deals more with AC system diagnosis, repair, and those sorts of issues, specifically towards, again, diagnosis and repair of those systems in the capacity that you can see on your screen. And if you look at the content area there and the tasks associated with it, you'll see that it drills down pretty deeply to get into those systems and diagnose and repair them to a great deal of extent. But what the A7 test does not do is it doesn't get into a great deal of detail with regards to refrigerant containment, the equipment, procedures, health and safety, and those sorts of issues. In addition, the A7 is just a certification test, the same products that ASE has offered traditionally for years and years, whereas the Refrigerant Recovery and Recycling Program, by law, needs to include a component of training and a quiz. So they're different animals. So the A7 does not equal ASE Section 609 or anybody's 609 for that matter. So be aware of that. It's kind of surprising to me, but we still have some people that will contact us once in a while and say, I can't believe A7 doesn't fulfill this, or is this the right one? It's not. You really need to have our program as a Section 609 program to fulfill that requirement under federal law. All right, so let's cover some refrigerant transitions. Originally, we saw R12 go away, which was a complete phase-out, and switch over to R134A due to ozone depletion potential from R12. That changeover was really completed by the 1995 model year, and it was fairly seamless. There was a lot of talk about some of the issues that it might present for retrofitting as we moved along, but a lot of the original issues didn't really materialize, so it wasn't as big an issue as perhaps the industry first thought. Now, R134A is a proven performer. It's proven out to be a very good refrigerant, but it has one real downside to it, and that is that it's a greenhouse gas, which is rated at 1430, and R134A is also the most abundant HFC chemical currently detected in the atmosphere. So there's a lot of it up there. And whether you buy into the greenhouse gas and global warming or not, those are the numbers of the basis of the science where things are headed. So everything is kind of predicated off of that, and I offer it to you on that basis. So again, R134A, a very good refrigerant, but unfortunately it has a high greenhouse gas level, and or rating, I should say, and as you'll see here momentarily, the number of 150 or below is kind of the number that we'll be looking at towards future refrigerant. I mean, that really comes out of Europe, but that seems to be kind of the number where things are going towards. Okay, again, we are in a global community. I just want to shift gears for a second, and I want to talk here about the European Union Mobile Air Conditioning Directive. I just spoke about refrigerant transitions here in the United States, but I just want to talk about the EU MAC directive momentarily here, mainly because it does have, again, a ripple effect on what's happening here in our country. So effective January 1st of this year, any new platform vehicles that were to be sold in EU member countries needed to use a refrigerant with a global warming potential of less than 150. And as I just stated, we have, prior to that, R134A with a number of 1430. So the directive there states exactly what it's supposed to be and exactly by when. In September of 2012, Daimler, the parent company of Mercedes-Benz, asserts that there were safety issues with the migration towards R1234YF, and we'll speak a little bit more about that specifically in a minute, stating that there were some flammability concerns, and at that time mentioned that they were going to move back away from R1234YF, even though they were mandated by the EU directive to use it in their new platform cars. This became such a serious situation that in France they actually stopped or started blocking, I should say, registration of vehicles that were not in compliance with the MAC directive. Okay, so now let's talk about HFO or R1234YF. Both designations are correct and both are acceptable by EPA definition in the US. So in the case of 1234YF, it has a global warming potential of 4 and an ozone depletion potential of 0. So obviously we've come a long ways from R12, and it looks like with this refrigerant we've come a long ways from R134A. There are indirect and direct greenhouse gas factors. The indirect is basically what comes out of the tailpipe of an engine that's running, say, a compressor on an air conditioning system, and the direct would be the refrigerant itself when released in the atmosphere. 1234YF is accepted under the EPA Significant New Alternatives Policy, acceptable subject to use conditions as all refrigerants are, meaning that at minimum there need to be unique fittings and label, along with perhaps some other use conditions. Those again are all defined on the ASE website per refrigerant in their acceptable charts. Now in the case of 134A in the US, it's really a phase down, not a phase out like originally with R12. It's not such a drastic thing. And we're looking at here for US vehicle manufacturers fuel economy credits to move over and make the migration to 1234YF. And you know, I just want to also add a reminder that this whole topic is changing all the time, and I'm talking specifically right now about 1234YF. So need to keep an eye on, you know, the fact that there could be other refrigerants that are emerging as this whole global situation kind of starts to shake out. One other point of contrast I just might want to make at this point is the movement to other refrigerants in Europe. I'd like to refer to a little bit more as the stick, and the movement towards other refrigerants here in the US, at least with 1234 at this point, is a little bit more of a carrot. It's done on an incentive basis, whereas in Europe it's done with a mandate, strict date, so on and so forth. So I just want to make that distinction clear, even though the two of them are interrelated. Okay, so real quickly, R1234YF and 134A have a very simple or very similar pressure-temperature relationship. So, you know, obviously it's one of the reasons that 1234 looked like it was a good transition refrigerant away from 134A. What we do know is that the container is going to be white with a red band. I've got 30 pounds on there, but really the cylinders that we've seen now are going to be specified more intense. So it should really be 10 pounds. Fittings are all defined per SAE J639. Again, there's going to be a unique label on the system. Price estimates that we've seen are in the $65 to $135 a pound range. Average R134A price currently is at $273, just to show you the contrast. And 1234 is not a retrofit refrigerant. Okay, it's a factory fill, and that's that. So it's not put out on the market for that reason. Now, I just want to address the price estimate here. It's forecast that that price will drop significantly once the manufacturing comes up with multiple plants. At this point, there's really going to be only one plant to manufacture the stuff. Okay, the recommended oil for 1234 is going to be PAG. Reverse retrofitting, I bring that up because there might be some of you thinking, well, if the pressure-temperature relationship is the same, why can't I just put 134 in a 1234 car. That's going to be no. My understanding is, as I know that EPA frowns upon it, they may at some point issue a regulation on that, but it's not something I would even think about. There is mild flammability with 1234, so there's a possible sales restriction. That is undecided at this point, and DuPont Honeywell is the sole manufacturer at this point, which does have some people concerned with potential availability. But again, it's forecast that they'll be building other plants, so the capacity should increase.
Dave, can I stop you for a second? We've gotten a couple of questions. Can you elaborate a little bit on the flammability of 1234?
Yeah, I can't get into a lot of science on it, but all refrigerants have to be reviewed for safety. In fact, actually, when EPA reviews a refrigerant under the SNAP program, they don't review it under the basis of it being a refrigerant that cools well. They review it under the basis of it being safe and not being an ozone depleter. It can't be a greenhouse gas above a certain level, and so on and so forth. During testing, 1234 has been shown to have mild flammability, but in tests that I've seen, you have to hold a flame to it, and it's hard to even get it to change the glow of any flame held up to it. So they have to disclose that. I think that in some cases more has been made out of that than it actually is. I'll be getting to something here in just a little bit to talk about safety further on into the presentation, getting back to the whole European Union and Daimler situation. But there's been hundreds of thousands of engineering hours that have gone into this refrigerant to ensure its safety. And now I think the 4th SAE Cooperative Research Project, which consists of representatives from almost all the car makers, to ensure that it's safe for use in their vehicles. So it's passed some extensive testing.
Great, thanks.
So I can't provide models to you right now as far as specifically from each of the manufacturers that are shown on the screen, because there seems to be some disparity about when those models will actually start using 1234, if they're going to use 1234. And again, over in Europe, it's a different thing. I don't want to water this down too much for that, because I know we're talking about U.S.-based situation here. But there is a plan by these organizations. This again is provided per DuPont, that these organizations have shown interest in using 1234 in their vehicles. The most pertinent ones to date are the Cadillac XTS and ATS sports sedan that got 1234 as a factory fill. But my understanding is, at least the latest information I have, is that the ATS was switched back to 134A because they had an issue. I think it was with some refrigerant lines and where they were located. It had nothing to do with the refrigerant's performance. It had to do just basically with system design that they needed to make some alterations to. So really, not much on the street. XTS Cadillac is really it at this point. Although I got to say, with things that I've seen in the industry, there are manufacturers that say cars could turn up hither and yon. So just be aware of that. Anything else on that, Tony? And I'll hold up if there's anything else specific to it before I move on.
I think you have it covered. There's a few other questions, but we'll hold those until we get to the question portion of the presentation.
Okay, back in September of 2012, Daimler, again the parent company of Mercedes-Benz, issued a press release stating that an investigation during a collision with a B180 class Mercedes showed that 1234YF ignited after a refrigerant line was severed and released refrigerant on the hot exhaust component. As a result of Daimler's findings, the company recalled affected vehicles and then switched back to R134A. Daimler has since performed more tests and for the time being does not plan to move ahead with R1234YF. Now, I've read reports of independent organizations, again the SAE CRP, DuPont, and others that have tried to confirm on the Daimler situation that they had, and they've not been able to repeat those results. I don't want to get into a lot of the details of what it was that Daimler did, but obviously the industry stepped up to try to confirm safety of this refrigerant, which now they confirm and say that, we've got a lot in this already. It is a very safe refrigerant. We don't see changing course over it. Okay, in response to Daimler's position, Volkswagen then came out last December and said that they were going to move in the direction with Daimler towards using CO2, which is carbon dioxide, which is also designated as R744. And that's when the SAE Cooperative Research Project version 4 was formed to go ahead and once again test the safety of R1234YF. GM, meanwhile, reaffirmed that R1234YF is safe and committed to it. DuPont also issued a response. And at this time, again, Daimler's findings are unconfirmed. One footnote I might want to add to that, too, is that there's a German transport safety group that has been contacted by DuPont for their formal findings and their safety tests about the Daimler situation. And as far as I know, DuPont has not yet got that information, but things are looking good for the safety right now of 1234YF. But that much I'll say. Okay, so let's talk about CO2 for just a minute here, R744. It has a ozone depletion potential of 0 and a global warming potential of 1, so it's the safest thing out there. I mean, it's a naturally occurring refrigerant. It's non-flammable. It's been used in commercial refrigeration for years, and it has been acceptable or deemed acceptable subject to use conditions per the EPA SNAP program. So as of this moment, if you were to go to the EPA website, you will find R744 on there, which means that there is a potential that you could at some point see an R744 system come your way. As of this moment, there's nothing, but it's potential because it is an accepted refrigerant at this point. And if it does find favor with the German manufacturers, my understanding is BMW is on board with that too. There's a possibility that we could be looking at CO2 systems. So we may not be headed towards just one refrigerant here as an alternative to 134A moving down the road. As I said before, it's naturally occurring. It's not chemical based. It does require much higher pressures for operation. So that does bring some safety considerations into play in terms of the service procedures. And since it's also naturally occurring with CO2 all around us, leak detection of it would require some different techniques for doing that. But there's nothing stopping, in Europe nor in the U.S. from a manufacturer using 744. The third refrigerant I want to talk about is R152A, also designated as HFC 152A. This is also a SNAP alternative by EPA that's accepted subject to use conditions. It has a proven history of performance, has low cost, roughly the same pressure-temperature relationship as 134A. It has a global warming potential of 124, which gets it underneath that 150 ceiling. However, it's moderately more flammable than 1234YF. And 152A is to be used specifically in new systems of proper design and not for retrofit. So let's take a look. But before I do that, I just want to make it clear to everyone here that the three main refrigerants I'm talking about tonight, 1234, R744, and R152A, are approved by the EPA only for new systems use. They are not retrofit refrigerants in any capacity. So I just want to make that real clear. With the possibility of R152 headed our way, we may see a secondary loop AC system emerging. These systems use a primary loop comprised of the typical components in a direct expansion AC system, so there's no surprises there. So we would be looking at, let's see if I can do this here. So we'd be looking at the primary loop side of this would be everything here, which is what we're used to. Only what we're used to is that this would then enter the passenger compartment. Okay? And the reason that a 152 type system with a secondary loop on it is being considered is that this prevents refrigerant from being in the passenger compartment should there be a leak with its more than moderate, or I should say moderate, flammability characteristics. So then your secondary loop would become over here inside the vehicle. And the way that these systems work is it works pretty much like a regular AC system here, but what it does is it cools a chiller rather than an evaporator, which cools a liquid. It would be probably ethylene glycol based. And there's an electric pump that pumps it up through and into the passenger compartment, where a cooler then works on the heat exchange. And other than safety aspects, the nice thing about a system like this is that since you don't have the refrigerant lines going all this distance, it would minimize the amount of refrigerant that's in there, especially on SUV type of designs. And could also work really good for hybrid vehicles in terms of cooling the battery and inverter. So we got to really start thinking about air conditioning systems anymore as thermal management systems. As we start to change vehicle technologies, these systems will be in charge of cooling more than just passengers. It could be cooling components, again, like battery and inverter, like some of the hybrid AC systems already are, but not using a secondary loop system here. Now, this isn't to say that a secondary loop system is the only type of 152 system that could be used. It could still use a regular direct expansion system, but it has to have something called a squib valve in it to minimize and prevent the rapid leaking of refrigerant should a breach in the system occur. But this type of system has been heavily favored, the secondary loop. So there could come a day where you see them. As of right now, such a thing is not out there on the streets, but maybe that day will come. Tony, do we have any questions coming in right now? I just thought maybe I might want to...
Yeah, let's pause and actually answer a couple of them. One question we got a little bit earlier, I'd asked the gentleman to hold on. You had made a comment about for hire. Or can you elaborate on that a little bit?
Yeah, let me, that's a good question. I'm glad that one came up. Is that basically under law, the terms that they use in the federal regs is that for consideration. For consideration means that you're being paid for working on an air conditioning system. And if there are instructors in the audience tonight, that would apply to you because you are really being paid for what you're doing if you're teaching students. Now, in the students' case, they're not getting paid for working on that air conditioning system. So there'd be kind of your dividing line. And federal law does make that a little bit clearer. But it's essentially, the line is drawn in terms of if you're working on an air conditioning system professionally, for hire, then you need to be covered by a Section 609 program.
Okay, the question actually specifically asked about fleet technicians, so I would assume fleet technicians would, like any other service professional, be covered under the 609 requirements. They would have to have the 609 certification.
Well,
is that correct?
That's possible. The thing is, though, when you say fleet, I don't know what they're working on. If they're working on a fleet type of environment where they're working on systems that are either passenger car based or MVAC-like appliances like I showed earlier, then 609 would cover them. But if they're going to be working on a reefer trailer or something like that, then that's going to be a 608 application. But in either case, they have to have some kind of credential, no matter the type of air conditioning system.
So if they're working on a refrigerant unit on a trailer, that would be, they would have to have the 608 certification. Is that correct?
Right.
Okay. So it's possible that a fleet technician would need to have both 609 and 608 certifications in their work environment.
Depending on the nature of their work, yes.
Okay, great. And another question came up. We may or may not be able to answer this. Will technicians be able to purchase this new refrigerant after mass production? I had answered yes, but you may need to show your 609 certification at the time to purchase it in bulk. Is that correct? Do we know how this is going to be sold?
Yeah, at this point, one thing I just want to make clear on that note is that early on, the sale of 1234 looked like it was going to be regulated with a sales restriction, the same way that it was done with R12. So therefore, you'd have to show your credentials. Okay. I don't know that that's going to be the case moving forward. There seems to be some jockeying back and forth between industry groups as far as, that you have to have that or you don't have to have that. It was once argued that because of its mild flammability, it was going to be covered under the Toxic Substances Control Act, so therefore would have to have a sales restriction, but now I've heard some of the other things. So until that final reg comes out, I'm going to have to just say, let's just stay tuned, and that's one of the discomforts of dealing with this topic, is that things are changing so rapidly. But to the extent that we could provide you with information tonight, that's what we're going to do, is hopefully show you some trends and likelihoods of where things are going.
Okay, and final question for this segment. At this time, will the current certification, if they hold 609, need to be updated, or is that still good to go?
As of right now, your current certification in 609 will be grandfathered going forward.
Okay, great. And I have a couple of others, but we can hold those to the end if you wish, and let you proceed.
All right. Okay, let's talk just a little bit now, switching gears, about contaminated R134A. There was a white paper that was released from the Air Conditioning, Heating, Refrigeration Institute, and I'll provide a link to that paper that was released about counterfeit cylinders containing a combo of R40, R22, and the other stuff you see on your screen, basically a devil's blend of things that could really mess up your air conditioning recovery and recycling equipment. And this stuff was, again, being sold as R134A. But with today's digital technologies, it's so easy to counterfeit things and make it look like it's valid that you really, really have to be careful. Again, it could jeopardize your safety, cause injury, or worse. Be diligent with a refrigerant identifier, and test, don't trust is kind of the rule there. Always use a refrigerant identifier and know what you're up against, because otherwise you could be in for a real bad day. To add more to that, there's no known portable analyzer prior to 2012 that detects R40, which could be in some of these contaminated and counterfeit cylinders. You might be able to use a portable infrared analyzer. Results on that are still not totally confirmed. You might be able to use halide torch testing or gas chromatography. I mean, we're getting into some elaborate things here, but the point in telling you all this information, and again, that URL will follow shortly, is that this stuff could be out there on the market, and if you come across a deal that maybe sounds too good to be true, it probably is. So what are the steps? Know your supplier, verify before using it, and if you find a contaminated system, isolate it to prevent mixing of refrigerants. It's just, again, you got to be real diligent about that. It's just not worth taking the chance. So based on where we are now, where are we? I'm going to add a qualifier to that, likely headed. And I'm going to say likely headed that, and the bullet's not even on the screen, is that we could be headed towards an air conditioning service world that does not have one successor to R134A. It could be some 152 systems, some 744 systems, and some 1234 systems. For the sake of standardization, one would hope that the industry will come together and see the light of 1234, and eventually we'll have standardized 1234 cars just like we did with 134, but right now it's too early to say that. As far as what's going to be in our program, there's going to be some training and certification revisions that are basically specified in SAE J2845, which deals with, again, the training and certification. It spells out content, addressing the refrigerants I mentioned. We're going to have new R3 equipment, refrigerant recovery and recycling equipment under J2843 that specifies how that equipment is to be designed and performance requirements. Refrigerant identifiers, J2912 and J2927. The reason that there's two different ones there is one of them could be an integral identifier and the other one could be external and plug into the refrigerant recovery and recycling equipment. And the reason that that identifier is integral in terms of operation is that one of the steps in recovering refrigerant is that, first of all, it's going to identify that it's the right stuff before it goes and pulls something into it that that may not be a valid refrigerant as far as 1234YF goes. New electronic refrigerant leak detector under J2913. And always remember that you need to comply with federal, state, and local regulations for flammable refrigerants. I showed the chart earlier. And one of the things also that I want to just mention is that air conditioning service regulations can vary not only with state but also in localities. Things such as topping off systems could be governed, so you need to be aware of that depending on where it is that you live. And just as an example, the state of Wisconsin has different requirements for technician training and certification than what's required by federal law. Okay, and with that...
Okay, Dave, I'm going to jump in with a few questions.
Yep, and then while you're doing that, Tony, I'm going to go ahead and I'm going to pop up the resources slide.
Great. We've had a couple of questions, and we may not be able to answer this one. Why don't we have an identifier for R40? One gentleman mentions that he understands there are these identifiers in Europe. Is there any reason you can think of why we don't have them available in the U.S.?
Well, I think the situation was that something that had really a practical use before, and now with situations like this popping up, now all of a sudden things can change, and a lot of this information is changing very, very rapidly because of the problems here that are presented. I don't know of any identifiers that are out since then, and some of the information I have in here might be a couple months old, but there's always a chance that a manufacturer may have come out with something with different sensitivities on it. So I don't really have a good answer for you other than to speculate a little bit, is that before having to deal with R40 wasn't such an issue.
This is a good question for everyone to ask their supplier, their equipment supplier, and check and see what they recommend or if they have anything in the pipeline coming out. And Dave, another question we're getting, what do we do with contaminated refrigerant if we come across it in the vehicle?
Well, refrigerant like that has to be sent to a reclaiming facility, and it has to be disposed of properly. There is a list on the EPA website of certified reclaimers. I don't have that list right off the top of my head. I could see if maybe I can find it for you. But it is something that's going to be coming out in our updated product. I remember working on that we'll have a list.
Okay, we have another question. Can they still use their current R134A recovery system? Don't they have to have separate refrigerant recovery equipment for each type of refrigerant?
Yeah, so in other words, I want to reframe the question, but I want to do this because I want to make sure that I've got it clearly, is to use their current 134A refrigerant recovery and recycling equipment for 1234. Is that the way you understand it?
Right. Can they use a 134A system? They just can only use it for 1234 or 134A. They can't use it for both. Is that correct?
Right. The equipment that's going to be compliant with working on 1234YF is going to meet SAE J2843. That's the standard, and the charge limits are smaller, so the sensitivities are going to be different. These newer systems have much less refrigerant in them, and they're going to do, again, some checking in terms of what's already in the system by use of either an internal or an external refrigerant identifier before it will charge the system. So it's a different animal in terms of the performance requirements.
Okay, and we're getting a lot of questions asking about emailing the resources that we're mentioning. I know we have the resources listed that you have in the slide in front. Can we also provide for example, resources maybe to get information on recycling refrigerants, disposal, that sort of thing? Do we have that at hand?
Well, the EPA Section 609 information that's on the screen there, that third link down.
Okay.
That basically takes you to the Section 609 page on the EPA website that then will take you into a vast amount of other areas all related to the service and repair, recovery, recycling of mobile air conditioning systems. So you should be able to find pretty much everything off of there, and or the technician's motor vehicle AC page. It's pretty much all there.
Okay, and they were asking about emailing the information, but they can just as easily pick this up by simply downloading a copy of this presentation from the recorded session. Is that correct?
Well, what we could do, and I don't know if this is any good for anybody, is we could drop these in. I think we could drop them into the chat window, but I don't know if they're going to be able to copy out of it on their end. I've never tried that. I could do it once and see if that'll get it over to them.
Okay. Short answer to the question then is we will try.
Yeah.
We have one other question here. It's probably more of a discussion. They're talking about supplies of 134A. Obviously that will be available for a period of time because we're going to have, just as we still occasionally run into an R12 system, we're going to have 134A systems available for some time to come. The question is, can we assume the demand of 134A will remain high and the supply will be lower, which will actually raise the 134A prices?
Yeah, I think that's all fair speculation, based on what we've seen with R12, but there is a distinction here I want to make really clear, is that R12 was a phase-out chemical, okay? R134 is a phase-down chemical. So the intent isn't to get rid of it altogether. The intent is to provide the car makers incentives to make a transition. Again, kind of the carrot rather than the stick. So R134 is going to be made for some time. There's no question about that.
Okay, and by the way, regarding the information on the screen, one gentleman says he did a print screen and copied it into a Word document and it worked just fine. So,
there you go.
Thank you, Doug.
Yes.
There's the answer.
Thanks, Doug. Good tip there.
And we've got a couple of questions. Again, how do they get a copy of this? Can you go over, we will make this available, how can they get it, that sort of thing?
Yeah, this session is being recorded, and we will make this available on the ASE website for recording at a later time or date. And this is a topic that we seem to garner a lot of interest in.
Okay, and with that, we seem to have caught up with all the questions. Dave, I'll kick it back to you for any final comments.
Okay, thanks, Tony. Just as a reminder to everybody, if you want to take our Section 609 program, you can do it. We do have a paper booklet. You can also take it online at asecampus.com. And we're also in the midst of our ASE certification test fall registration period, which started on September 1st, goes through November 21st, with testing from October 1st through November 30th. And with that, I want to say thank you to everyone. Again, watch your invites coming in. This will not be the last time that we address this topic, as the changes that I talked about tonight become more concrete in terms of what they are in our product. And as other changes continue to materialize in the industry, we'll bring this one up again, and we'll continue to talk about ASE service stuff. So I hope that this was a benefit to you, and I want to thank every one of you for joining us. And on behalf of Julie White, Tony Mallon, and myself, thanks for joining us. And we hope to see you soon.